Okay, AP Environmental. This is the final subtopic for Unit 5. So, this was a massive unit, definitely the biggest unit that we've covered up to this point. So, we are going to conclude it today, again, with topic 5.9, which deals with the impacts of mining. Again, this unit is titled Land and Water Use. That's the title of the unit. So we've been really talking about different things that we do to the land, especially agriculturally. We spend a lot of time on that. We spend a lot of time talking about how we use water, move water around, things like that as well. So there's one more like major um, I guess, thing that we do, to our land, and that's mine. So we're going to talk about mining today. But we're going to kind of get started today with um, kind of a topic that you might think doesn't have much to do with mining, but it actually does. Gas cars versus electric cars. This has been a lot, or this has been in the news quite a bit, recently, last several years, as far as like should we be purchasing more electric cars or more gas cars? Which one of them is better, for the environment? Um, so let's kind of go through just a few things real quick. When it comes to purchasing an electric car, I guess one of the biggest advantages is that we're not going to be using as many fossil fuels, right? I mean, we're going to be thinking, well, we're buying an electric car, so we're going to be doing something really good for the environment. We're not going to be using as many fossil fuels and giving off as many greenhouse gases like CO2, and that's absolutely the truth. You definitely are not going to be giving off as many greenhouse gases, not going to be polluting our atmosphere, contributing to global warming and climate change, all that stuff. So I'm sure people that purchase electric cars probably feel really good about themselves, environmentally, because they're kind of doing something to help, right? Maybe they're going green, right? Maybe that's what they're doing. It also can help save money. I mean, you're not paying money to purchase gas. You might be having a little bit higher of an electric bill, but at least you're not spending that money again on fossil fuels. Now, some of the negatives associated with buying a electric car versus a gas powered car. One of them is the price. Electric cars historically have been more, even though the prices are dropping. They're making these cars a little bit more affordable, which has been a good thing. I know when they first came out, they were quite expensive, but now they're tending to be a little bit more competitive, or competitively priced with gas powered vehicles. But still, you're probably going to pay a little bit more for an electric car of the same caliber as a gas car that you might purchase. Now, the other big negative deals a lot with what we're going to be talking today about, the construction of an electric car. To obtain a lot of the materials that are needed to construct an electric car requires a lot of mining. Here's just some examples. Here's an electric car, and just looking at all the different components of the car. This doesn't even get into some of the things that are on the inside, but um, you see all these terms, things like lanthanum and praseodymium and neodymium. A lot of these things are what we call rare earth metals. They call them rare earth because they're rarely found on Earth. We don't have a lot of, for example, praseodymium on this planet. There is some, but there's not very much of it. So whatever praseodymium, that we mine for and use, to help us build these electric cars, there's only so much. It's not like, praseodymium doesn't like grow on trees. It's not like you can't like plant it in the soil and, grow a praseodymium plant. I mean, these are metals that are found in the Earth's crust, that we only have a certain amount of. So every time we mine for these things, not only do we do a lot of disruption to the planet, do a lot of soil damage and land damage, but we also are reducing these finite resources that we only have so much of. So that's kind of a big issue. So the way I look at gas powered cars versus electric powered cars is, I guess, which one is the lesser of two evils? Do you want to keep using a gas powered car and keep polluting the atmosphere, with greenhouse gas emissions, or do we want to buy an electric car, which may not be polluting the atmosphere as much, but we're driving a vehicle that probably involved a lot more mining, and tearing up of the Earth's surface. I mean, there's just I guess, a different um, environmental set of problems that are associated with electric cars than they are a gas powered vehicle. So don't necessarily think like you're doing this great service to the environment, by buying an electric car versus a gas powered car, because you're really not. It's just a different set of problems that you're kind of involved with. So I don't know which one is better, one or the other. I don't know. Until I'm convinced otherwise, I'm going to probably keep driving my gas powered car. But maybe one day, if electric cars are really affordable, and they can make them in a way that doesn't involve the mining of so many maybe rare earth elements, then maybe I'll go ahead and buy an electric car. But I don't know. Until that point comes, I don't know. All right, so let's talk about mining today. Um, first of all, what do we mine for? We mine for a lot of different things. Minerals like diamonds, for example, salt. We mine for that stuff. Those are just kind of some obvious ones. Metals, things like copper and gold and aluminum. These are things that we have to mine for. And finally, fossil fuels. We'll talk a lot about this one in the next unit. But for example, coal. Coal is something that we have to mine for. Now, there are some terms here that I want you to know before we kind of go any further. So just go through some of the terminology here. Again, the term mining, it's a process of removing an economically valuable material. Again, that could be coal, it could be gold, it could be salt, whatever. It's something that's valuable, economically to someone. Some things are worth more money than others, obviously, but it's just the process of removing that material from the ground. The term finite resource, it's also known as a non-renewable resource. This is something that can't be readily replaced. If you remove coal from the ground, it takes thousands and thousands of years for that coal to form. So if you remove it, it's not easily replaced. So that's a finite resource. The term ore, O-R-E, ore is basically the material that you remove from the earth that contains this valuable material. For example, this picture on the bottom right, this is a picture of what we call copper ore. We know what copper looks like, right? Like a copper pipe, for example. This doesn't look anything like copper. It doesn't look like a copper pipe or whatever, right? But that's because this is the ore. The copper is embedded inside of this piece of rock, basically. So it's kind of raw. It's not refined. It's not, the copper hasn't been taken out of it yet. So we have to do something to this ore in order to remove the copper. We call that refining. Refining is just the process of taking out whatever valuable material is in that ore, so that you can sell it or do whatever you need to do with it. But refining typically requires usually chemicals. We'll talk about some processes today that require chemical use to get rid of or to remove the ore. Sometimes it takes a lot of fossil fuels, just for the process to take place, and also water. We've talked about water use. Well, we need to use a tremendous amount of water just to refine some of these ores that we remove from the surface. High quality ores and low quality ores. High quality means that you don't have to refine it very much. All right. I mean, every ore has to be refined, but the high quality ones means that you don't have to refine them very much in order to remove any impurities or to isolate that valuable material. A low quality ore would require lots of refining. So lots of chemical usage, lots of fossil fuels, lots of water would probably be needed for that process. The term reserve is basically, how much of this resource do we have? For example, this chart here shows us just some of the different reserves that we have. I mean, I don't know. We'll take aluminum for example here. Aluminum, according to this chart, the global reserve of aluminum is about 330 years. So what that means is, on our planet, if we keep using aluminum the way that we use it, we've got about 330 years left worth of aluminum. But however, the U.S., our reserve is a little bit different. Again, if we keep using aluminum and keep mining aluminum the way that we are, we're going to run out of aluminum in 2 years. So the reserve of aluminum in this country is not very high. So what should we do about that? Well, one of the things that we do is we recycle our aluminum, right? So if you can recycle it, that probably means you don't have to mine for it all the time. You can just keep reusing and reusing and reusing. And in this country, there's a huge, aluminum recycling, community. I mean, people recycle their aluminum all the time, right? So that's kind of a big deal. Other reserves are a lot more, but aluminum is one that we just don't have a lot of, so we definitely need to recycle that. All right, there's two different types of mining. One type is called surface mining, and again, you can imagine it happens at the surface. We also have what we call subsurface mining, which happens underneath the surface. So we're going to talk about both of these today and kind of just get into the generalities of both of them. So we're going to start with surface mining. All right, so surface mining, if you look at this picture here, let's say, for example, we're mining for coal, right? So here's the coal here. It says it's a coal seam. It's just the coal that's under the ground. But above that coal, right, you have soil, right? You have dirt or rock or whatever you have. We call that the overburden. The overburden is basically the soil or the rock that is above the ore. It's above the resource that you're going to mine for. So you can imagine if we're going to be surface mining, we're going to be digging through all of that overburden. We're going to really be disrupting the land in order to access that particular resource. This picture on the right is showing you this, right? This is, I don't know what type of a mine this is, but obviously it's a surface mining operation and they're disrupting a lot of the land in order to access a specific resource. There's a term here called mining spoils. Mining spoils is real simple. It's basically the overburden. It's the soil that's above the material that you're mining for. But once we dig up that soil and we move it to a new location, now we have to change the name of it. Now we call it spoils. So what you're seeing here, all of this, this big, mound of dirt and rock. This was overburden at one time, but now it's been scooped up, it's been moved somewhere else, and now we call it spoils. So spoils is just big, heaps of dirt and rock that we remove in order to access the material that we're going to be mining for. Now, this is just a little tiny pile, right? A little tiny mound of mining spoils. Some of these things can get massive. I mean, the amount of overburden that can get removed can be a tremendous amount, and you'll see that in a few minutes. All right, now when it comes to surface mining, there's three Oh, pretty big issues with it. I don't care what type of surface mining you're talking about. Every single type, involves, three major environmental problems. One is it fragments habitats. Anytime we're disrupting the land, disrupting the soil, that has an opportunity to fragment a habitat, which can lower biodiversity. We can degrade the soil. We can ruin the soil. We can make it less fertile. That's a big issue because we only have so much, right? It also involves some type of pollution, whether it be air pollution or water pollution or even noise pollution. That is a type of pollution. These are all things that can affect people and animals and plants and things like that. All right, so let's get into the three different types of surface mining. We'll just kind of briefly talk about each one of these. Strip mining, open pit mining, and something called mountaintop removal. This is strip mining. If you look at this picture here, it's all strip mining kind of looks very similar. It's almost like they create these little steps. They call these things benches, and they just kind of strip away layer upon layer upon layer. This particular type of mining usually takes up a lot of surface area. So there's a lot of land that can get disrupted because of this particular type of surface mining. Another type is called open pit. Open pit is kind of like strip mining, but it's really, really deep. You can just kind of see this giant hole in the ground. This is a one specific mine. It's called the Murmy mine. It's in Siberia in Russia. And this mine is 1,700 feet deep and it's 4,000 feet wide. I mean, it's similar to strip, but it just gets really, really deep. I don't know how deep it has to get to call it an open pit mine, but basically, if you got a giant hole in the ground, it's basically an open pit mine. Okay, if you don't have a giant hole in the ground, it's probably going to be a strip mine, but whatever. It's kind of, I think, kind of obvious which one is which. But I mean, these mines are just massive. I mean, you can kind of see kind of an aerial view of this mine, kind of like a neighborhood over here. I mean, you can just kind of see how big this thing is. This kind of puts it into perspective as well. This little tiny speck right over here, that's a truck. I mean, that thing is like, it looks like a little speck of dirt. It's really tiny compared to the size of this mine. So you can just kind of see how big this hole is. That I think kind of puts it into perspective for us. This is called mountaintop removal. And mountaintop removal is exactly what it says it is. They literally just blow up the tops of mountains, using explosives, dynamite, TNT, whatever, in order to expose, the resource underneath, whether it's copper or whatever it is that they're going to be mining for. So they literally just blast off the tops of mountains in order to do this. So you can imagine, the land disruption and the habitat disruption that this type of process could occur. Subsurface mines, these are mines that are below the surface. Typically 100 meters or so below. That's usually how deep they get, maybe deeper than that. The one thing about subsurface mining is it doesn't involve a lot of overburden removal. I'm going to go back real quick to one of these pictures I had. Here it is, right here. So like this is subsurface mining here. And yes, they do have to, like dig a hole. All right. But I mean the amount of overburden that gets removed is a lot less than, let's say, a surface mine. All right. So in that aspect, it's kind of a good thing because they don't remove as much overburden. But some of the drawbacks to this, you got people working underground, like in a mine where they're constantly removing rock and removing ore. I mean, it can be kind of dangerous. I don't know if I would ever want to do this. I mean, you kind of hear in the news all the time about like miners that get trapped, under these mines. The mines collapse. I mean, there's even a movie. I can't remember the name of it, but it was a couple of years ago, and it was a mining operation in South America, where a mine collapsed, and I want to say it was like I don't know, 30 or 40 miners got trapped in this thing, and they were in there for like weeks upon weeks. They eventually, I believe, got them out. Yeah, they did get them out, but oh, I mean, you can imagine being trapped underground, for weeks at a time. So not a good thing, but that can happen. Plus, miners can get really sick. I mean, they're working underground. I'm sure the air quality underground is probably not very good. A lot of miners get lung cancers. There's diseases called black lung disease, for people who work in coal mines, for example. Now, in the United States, there's a lot of intervention as far as like restrictions and laws that prohibit certain types of operations to occur underground. There's a lot of safety measures that have to be taken place. So a lot of the miners are very protected in the United States, which is good. But in other countries around the world, that's not necessarily the case. So, usually the mines in the U.S. are about as safe as they can be, but in other places around the world, some of these operations are like totally bootleg, and a lot of bad things can happen in those mines. So, not good. All right, so this picture here just kind of, I think, just kind of summarizes the different types of mining. Again, mountaintop removal, your open pit, your strip mining back here. Then you have your subsurface where people are working under the ground to actually remove some of those ores. All right, I do want to cover really quick here two different chemical processes that can occur because of mining. This one is called cyanide heap leaching. Cyanide heap leaching is used to remove gold. It's used to remove some other things as well from ore. I mean, for example, here's a picture of some gold ore. Like you can imagine, there's gold in there, but there's also a lot of things that we don't want. I mean, this is not pure gold; it's an ore. So one of the things that we do with gold ore, in order to remove it, is we apply a solution of cyanide to it. Now, if you don't know anything about cyanide, cyanide is a poison. It's not good. You don't want to get that into your body. You don't want to drink it. You don't want to eat fish that's contaminated with it. Not good stuff. But we use it so that we can remove the gold from the ore. So, what do we get after we do this process? We get gold, and we also get what we call a cyanide slurry, which is basically just a big liquid batch of mess. I mean, it's just stuff that you do not want around you. You don't want to dump this stuff into a river. You don't want to dump this stuff in the soil. You don't want to be anywhere near it because it's extremely toxic. So, if we're going to remove gold and we're going to get this big heap of mess, what do we do with it? Well, in the United States, what we do with it is we just kind of store it in tanks, and that's it. We just kind of get these big metal cylinders and just put in all the cyanide mess and let it sit there, which takes up space, but it's there. I guess it's somewhat protected. Hopefully, nothing happens to these tanks. Now, in other countries around the world, what do they do with it? Because maybe they don't have tanks. So, guess what? It ends up getting into rivers and lakes and streams, and it ends up polluting. So, not good. But in the US, I guess we're somewhat conscious of this mess and we got to deal with it. All right, now another big problem chemically with mining is something called acid mine drainage. Acid mine drainage typically happens when you have abandoned mines. You gotta remember, I mean, like there are mines in this country that haven't been operational in over 100 years. Like back in the 1800s or something. Like some prospectors, discovered a mine and they mined whatever they could out of it, and then they just packed up and they just left one day. They just left this thing like wide open. I mean, there are hundreds of these mines in our country that are just wide open like this, and maybe they tried to seal them off, the best they could, but whatever. They probably didn't do a very good job. So anything that's in that mine, if it gets out, could be problematic. And this is what we call acid mine drainage. Now, here's how this works. One of the things, and there's a chemical equation here, so I'm going to do a little bit of chemistry, but I'm going to kind of make it kind of simple. All right, so if you look at this equation, right, we see a bunch of chemical symbols. This takes us back to our chemistry days, but there's just a few things here that I think we need to be somewhat concerned with. The first one is this right here. This is FeS2. It's also known as iron 2 sulfite. It's commonly known as pyrite, or even commonly known as what we call fool's gold. Maybe you've heard of that before. But pyrite is a pretty common mineral, chemical, solid that's found in abandoned mines. It's really common. Okay. Now, the thing about pyrite is if it's in a mine, in an abandoned mine, over time it will chemically react. And two things that it reacts with are oxygen gas, which is everywhere, including in an abandoned mine, and also water, which there's probably also a lot of in an abandoned mine. So when pyrite reacts with these things, it undergoes oxidation, which we're not going to get into, but you might remember that from chemistry. But when it reacts with these two things, it produces these products. Now, of these products, the one that you need to be most concerned with is this one right here. This is sulfuric acid, H2SO4. Sulfuric acid is an acid. So if in an abandoned mine you have a bunch of pyrite and it's reacting and producing a bunch of acid, sulfuric acid, if that stuff gets out of the mine and it gets into a waterway or a river or a lake, I mean, think about what acids can do to water. One of the things that they do is they lower the pH of water. So now you can have, for example, a normal river with some healthy fish and plants and whatever. And now you've got river water that's had its acidity lowered, which is probably toxic to fish, and that could kill a lot of organisms. Another problem with sulfuric acid is as it kind of drains out of the mine, it has the ability to pick up any other metals that might be in the mine, things like zinc and copper and silver. If any of those things are in the mine, the sulfuric acid will kind of react with them and then pick them up. And then those things will end up getting into the river water. And anytime these metals get into the water, they are toxic to fish. So a lot of times, I'm going to go back to this picture real quick. See all this like yellow water? All right. That is the drainage from the mine. That water is highly acidic. It is loaded with heavy metals. And if that stuff were to get into a larger body of water, let's say a river, or let's say a lake or a stream, there can be a tremendous amount of contamination. So, I mean, we would have to really seal this thing up to make sure none of that gets out. But again, there's a lot of abandoned mines where we don't even know where they are, and they're causing these issues. So, kind of a big problem. All right, this last slide here, I think, kind of really summarizes a lot of the environmental impacts that both surface mining and subsurface mining has, on the environment. It talks about the effects on the air, effects on the water, effects on the soil, effects on biodiversity, and even effects on humans. So this might be a good slide to kind of look over and study before your next test or your next quiz. All right, guys, have a good day. That ends the unit. That's it for Unit 5. So I will see you guys soon. Take care.